Hey guys, this is Camden's Takes. If you saw my last video, we went over some star temperatures, but this time we're going to go over them individually. While there are so many right now, we'll go over all of them in the future, well, in different videos, but right now this is a sample of colors and sizes and temperature. And in this video, we're going to talk about main sequence stars, which is the common type to fuse hydrogen into helium, and we'll have a neutron star, which are giant stars collapsed core left over from supernovas packed with neutrons. And we'll have pulsars, which are spinning neutron stars, and we'll also have hypergiants, which are the largest types of stars in the universe, and we'll also have supergiants, which are also another type of really large star. And we're also going to have a giant star, which is the biggest a medium star gets, like our sun. And then we're going to go over white dwarf star remnants, which are what's left over after a star like our sun sheds its outer layers. And we're going to have a brown dwarf star, which have masses between gas giant planets and small stars, which they can't fuse hydrogen, but they do emit light and heat from radiation, and black dwarf stars, which are what's left over after a white dwarf burns out completely. So the first star we might actually know very, very well, and that is a yellow dwarf, which is our sun, that is the center of our solar system, which we know. The next star is actually near the solar system, which is an orange dwarf, which is Alpha Centauri b, in a triple star system with stars Alpha Centauri a and Proxima Centauri, located in the Centaurus constellation. The next star actually has some planets. TRAPPIST 1, which is a red dwarf star, which is cooler and dimmer than the sun, which has 7 planets of its own, including 3 in the Goldilocks zone. You can find it in the constellation Aquarii. The next star is actually technically invisible to us, and that is a black dwarf star, which is left over from what a white dwarf cools and burns out completely, so there's no energy or fuel left to burn. The next star is actually known as the missing link between planets and stars, and that is Teide 1, which is a brown dwarf star with masses between gas giant planets and small stars. They can't fuse hydrogen, but they do emit light and heat from radiation within them. And they don't fuse hydrogen, but they do fuse deuterium. So they're pretty much a failed star. You can find it in the constellation Taurus in the Pleiades cluster. Next one is one of the bigger stars in this video, which is one of the brightest in our night sky. The first giant star is Arcturus, which is a red giant star, which used to be a star almost identical to our sun at the beginning of its life, but now it's a really large star compared to the sun. It's the brightest star in the Betelgeuse constellation, but along with Spica and Regulus, it's also one of 3 stars in the Spring Triangle asterism. It's also one of 4 stars that make up the Great Diamond asterism, along with Spica, Denobula, and Corciroli. Next is a lot like our sun, but bigger. Eta Piscium is a yellow giant, which is a G7 type star, which is cooler than our sun, which is a G2 star. You can find it in the constellation Pisces. Next is, really hot and burns fast, which is Bellatrix, which is a blue-white giant star. It's one of the hottest stars in the sky and one of the brightest too. Blue stars use up their energy really fast and pretty quickly, so their lives are pretty short. It's one of the brightest stars in the Orion constellation, and that is where you'll find it. Now we're moving to something even bigger, which is another one of the top 10 brightest stars up in the night sky, which is a red supergiant named Betelgeuse, which is one of the rarest and largest types of stars that will supernova and become a black hole or neutron star. You can find it in the constellation Orion. It's the second brightest star after Rigel. Next, we're going to go to something yellow, like our sun, but it's bigger than a yellow giant. Beta Aquarii is a yellow supergiant, which is a G0 type star, which is hotter than all the other G-type stars, and it's the brightest star in the Aquarius constellation. And now we're going to go to one of the hottest and rarest types of stars in the galaxy. a blue-white supergiant named Rigel. It's much larger and hotter than our sun, so if it was in our solar system, it would go all the way past the asteroid belt. It's the brightest star in the Orion constellation. You can find it in the hunter's leg on the right. The next one I actually mentioned in the last nebulae video. I'll have a link to that in the description. And that is at the center of the Crab Nebula, which I mentioned in the last video. The Crab Pulsar, which spins 30 times per second. That's left over from a giant star's supernova, so it's a giant star's collapsed core. It was about the size of a full moon in our night sky when the supernova happened. You can find it in the Taurus constellation with a telescope. The next one is actually a remnant left over from a star similar to our sun. And that's a white dwarf star named Procyon b, which is actually a binary star with Procyon a. Procyon b used to be a really large star, but it used up its energy really fast, so now it's just a really dense white dwarf core. Along with Procyon a, it's the brightest star in the constellation Canis Minor. Next is a star that's actually binary. And that binary star is named Sirius. It's also known as the dog star. It's the brightest star we see at night, but there's actually two of them. Sirius A, a white main sequence star, Sirius B, a white dwarf star, slightly smaller than Venus and Earth, and Sirius B is known as the pup star, located in the constellation Canis Major, and it's the brightest star in there, and it's the brightest star we actually see at night. Next is the rarest type of star, or one of, if not. And that is Cassopia, one of the rarest types of stars and one of the biggest, which is a yellow hypergiant, but it's actually not the only one, located in the constellation Cassopia. And finally, this one is one of the largest known stars ever. Red hypergiant Scuti, which used to be the largest star until Stephenson 2-18 took over. You can find it in the Scuti constellation near the center of the Milky Way. This is actually just part 1, so I'll have a part 2 coming.